Okay, you're welcome back to the Living Well tutorials with Uncle K. From the last lessons, we were treating the application of the fundamental mathematical principles. So I listed some principles, among which was dividing both sides by something, which we treated in the last lesson. So today we are moving on to the next principle, which is collecting like terms. So remember, the reason for these lessons, for this series, is so you could know the right time, the right stage at which a particular principle is rightly applied. So just as I did for the last lesson, I gave some examples which I solved, and while we solved the examples, I explained some things, and I believe they were understandable enough. So the same way we go this morning. So the next principle is the principle of collecting the like terms. So that's example 2. So there are 6 examples listed here. So while we solve them, you would understand more. So what do I mean by collecting the like terms? As it is said, collect like terms. So it shows that there must be some terms that look alike. So you bring them together and evaluate them. Then that leads you to the final answer. I mentioned something in the last lesson while we treated dividing both sides by something. So dividing both sides by something usually precedes the final answer. But before you get to the stage where you have to divide both sides by something, this comes first before you go into that. So you collect like terms most times, then you divide both sides by something, then you get your final answer. So example 2a, we have the question says solve 6y minus 24 plus 21 equals 6 minus 3y. So is it right to apply the principle of collecting the like terms here? Okay, or should we start from dividing both sides by something? Okay, obviously the variable we are finding here is y, and to divide both sides by something, the term containing the variable we are looking for has to be on one side and every other term on the other side. We have 6y here, we have 3y here. So these are the terms containing the variable y we are looking for. So of course we can't divide both sides by anything here. So now let's see if we could collect like terms. So these, just like dividing both sides by something, I mentioned 2 things that needs to be satisfied before we do that. So the first is that the term containing the variable we are looking for must be on one side and every other term on the other side, if you remember. And the second is what to divide both sides by. Of course, you have to divide both sides by the the coefficient of the variable you are looking for. So likewise, while you apply the principle of collecting the like terms, there are things you should ascertain before you do so. So the first thing I will mention is that you have to ascertain there is a straight line equation, meaning no fractions at all. Make sure there are no fractions. And secondly, make sure that there are no brackets. All the brackets have been dealt with, have been opened. So these are the 2 things you just have to ascertain before you proceed to collecting the like terms. Okay? What are the terms we have here? We have 6y. Is there any term that looks like 6y? Of course. 3y looks like it. So we collect them. Other terms, we have 24, we have 21, and we have 20, and we have 6. These terms also look like alike. I mean, they look alike in the sense that they are all whole numbers. So we could apply collecting like terms here. Why? Because it's a straight line equation, as I said, and secondly, there are no brackets here. So let's proceed. So it is advisable to start with the term that has the variable you are looking for. Start with it and end with other terms. And secondly, I would also advise the ones that have plus sign come first before the minus, just to avoid negative confusion and all that. So if we start with 3, 6 is bigger than 3. So we make sure that we maintain a side that has 6 with it. So 6 is greater than 3. So we make sure 6 is the plus and 3 can be the plus or the minus, whatever it is. So 6y is on the left hand side, which is the biggest among the terms that has the variable y we are looking for. So we maintain it to be at the left hand side. So for example, now if 6y is here and is the biggest among the terms that has the variable y we are looking for, then you maintain that side, that is all the terms that have the variable you are looking for, you maintain it to be on that side to avoid negative answers and confusion. So this will now give us 6y. Is there any other term that has y? Yes. Minus 3y has y. So you bring it to this side. And remember, when any term crosses the equals to sign in mathematics, the sign changes. So if it was minus, it becomes plus. If it was plus, it becomes minus. So minus 3y will surely give plus 3y. So after all these, there are no other terms here that has the variable y we are looking for in it. So we just make sure every other term is on the other side. So you introduce your equals to sign, and also after introducing the equals to sign, also take note of this to avoid confusion. You write all the terms that are on the other side already first. Reason being that they don't have to change signs. So 6 is already on this other side, so you don't have to take it to any other side again. So you just write the 6. Are there other times that looks like 6? Yes, minus 24 does. So it comes to this right hand side to become plus 24. And then plus 21 also comes to this other side to become minus 21. Okay, so we proceed. Another thing I would love to mention is you work mathematics downward, not sideways. So take note of that. Also to avoid confusion. When you are having more than one equals to sign in an equation, then it could cause confusion. So that's why you have to maintain solving downwards and not sideways. So 6y plus 3y. Okay? Now, we have collected the like terms. 6y and 3y are like terms. They are together now. 6, 24 and 21 are also like terms. They are also together. So we have collected the like terms. Sorry, I forgot to write the principle applied. So we could collect like terms. So that's 6y plus 3y equals 6 plus 24 minus 21. So the next thing now, having collected the like terms, you evaluate. 6y plus 3y will give 9y. Just like saying the reason why we collected the like terms is so that we could evaluate them. Imagine you have 6, okay, for example, if this is 6y and this is 3x, they are not like terms, so you can't evaluate them. It's just like saying 6 naira plus $5. That won't give you, will it be 11 naira or $11? You get what I'm saying, right? So it has to be the same. It's just like units in science. So 6y plus 3y. So they are both y. 6 naira plus 3 naira. They are both naira. So that will give you 9 naira. But if you have, imagine adding 6 oranges to 5 apples. What will that give you? Confused, right? So that's the essence of collecting the like terms. So you make sure that they are like terms and then you evaluate. So 6y plus 3y is 9y equals, so 6 plus 24, that's 30. 30 minus 21, that's 9. Yeah, that's 9. Okay, having evaluated the like terms that we have here, we can, you agree with me that the next principle to apply here is to just divide both sides by 9, because 9 is the coefficient of the variable you are looking for. And 9y, which is the term that has that variable in it, is on one side, while every other thing is on the other side. So the next thing now here is to divide both sides by 9. Not this 9, but this 9, the coefficient of the variable you are looking for. So on the first side we have 9y, and on the other side we have 9. So you divide the first side by 9 and also the second side by 9 too. 9 here 1, 9 here 1, 9 here 1, 9 here 1, and therefore don't mind the way I'm just splitting the board anyhow, please. So here we have just y equals 9. So, and that's our final answer. Okay, let's quickly go to the next example, example 2b. Example 2b says if 4x minus 2 equals 3x minus 5, find 7x. Please note this. We are not just finding x here, which is the variable in the equation. We are asked to find 7x. So the idea is you find x, which is the variable in the equation first, then you now find 7x. Without finding x, you can't find 7x. So how do we find x first before we now find 7x? So remember, we are treating the principle of collecting like terms, but before then, could we divide both sides by anything here? No. Why can't we? Because the term which has the variable we are looking for here is not even just 1. Talk less of saying that it has to be on one side and others on the other side. So 4x has this variable is on one side, 3x has this variable is on the other side, but it should just be 1, and it has to be on one side, and every other term must be on the other side. So you can't divide both sides by anything here. So let's test if we could collect like terms. Could we? Before we could collect like terms, remember I said it must be a straight line equation without fraction. Of course, it's a straight line equation and it's without fraction. And also, there must be no bracket. The brackets must have been opened. So it has satisfied both rules. So and therefore, we could collect like terms. So So to collect like terms, you note the term that has the variable you are looking for. So to collect the like terms, we have 4x. Is there any other term that has the variable we are looking for in it? Yes. 3x, but it's on the other side, so it comes to this other side to become minus 3x. Is there any other term which has x? No. Then you introduce your equals to sign. Yeah, remember I said dealing with the other terms, you write the ones that won't have to change signs first. Minus 5 doesn't have to change sign, so you maintain it, minus 5. Then another whole number here is minus 2, but it's on the other side. When it comes to the right hand side, it becomes plus 2. Okay? So we proceed. 4x minus 3x. That's 1x, which is the same thing as just writing x, equals minus 5 plus 2. Okay, I have the understanding that some students also find this very confusing. Minus 5 plus 2. Now, don't mix it up. This is different from minus 5 times plus 2. So, let me quickly just digress and explain that. When you are multiplying signs, I want to recall that we know that plus times plus is plus, minus times minus is plus, plus times minus is minus, and minus times plus is also minus. So the summary of this thing is that if the signs are the same, the multiplication result will be plus. That is, plus multiplied by plus. So the signs are the same. The result for the multiplication will surely be plus. The same also with minus. Minus times minus, the signs are still the same. The result for the multiplication will be plus. But if the signs are different, you are multiplying numbers with different signs, one plus, the other minus, or vice versa, the result, the multiplication's result will be minus. So plus times plus, the sign is the same, plus. Minus times minus, the sign is the same, plus. Plus times minus, the sign is different, minus. Minus times plus, the sign is different, minus. But this doesn't apply with just adding and subtracting numbers. When you have, for example, the one we have here, minus 5 plus 2. We are not multiplying minus 5 by plus 2. So you don't apply this with these. You will be wrong doing that. So the right way to go about stuffs like this is you just have it at the back of your mind that any number that has the negative sign is a debt, while the one that has the plus sign is what you have. Okay, so in this case now, you have a debt of 5 naira and you have 2 naira. So if you give the person you owe 5 naira, you give the person 2, you will agree with me that you will still be owing 3 naira. So owing, debt is minus, remember. So debt of 5 naira and you have 2 naira. So I have a debt of 5 naira and I pay 2 naira. So I still have a debt of 3 naira. So that will give you minus 3. So in this way, you won't be confused. So here, 4x minus 3x is x, which is the same thing as 1x, equals, I have a debt of 5 naira and I paid 2 naira. So my debt still remains 3 naira. And therefore, the final answer, okay, not the final answer, remember we have to find 7x. But we found x. X equals minus 3. We don't have to divide both sides by anything here because luckily for us, the coefficient of x here is 1. And therefore, we don't have to. Had it been something like maybe 21x, remember you will have to divide both sides by that coefficient of x. So you just proceed to finding 7x. 7x, therefore 7x equals 7. X is 1 minus 3, so you just put the value there. So 7x equals 7 times minus 3. So this is where you apply these rules. Now remember, this 7 here is actually plus 7. So plus 7 times minus 3. So the signs are different. Definitely it will be minus. If the signs are different, remember, it will be minus. So that will give us minus 21. So you multiply the signs first, plus times minus minus, then you don't multiply the numbers. 7 times 3, 21. Okay? Oh, I hope these won't be confusing. Oh, okay. So that you won't have to go and be dividing both sides by anything. Okay? But we are looking for 7x. 7x is minus 3. So the final answer will be minus 21. Okay, I think it's better this way. Alright, so quickly let's go to the next example, which is example 2c. Example 2c, we are asked to simplify a very long this thing. Okay, permit me to okay, we are asked to simplify 2x squared plus 5x minus x cubed plus 3x raised to power 4 plus 7x minus 21. I would love it to contain it at once. I'll have to reduce the size of my handwriting. Okay. Example 2c. 2x squared plus 5x minus x cubed plus 3x raised to power 4 plus 7x minus 21 minus 4x cubed plus 8x squared plus 16. Don't mind me. Sorry, how? That's 16. Okay, the question says we should simplify these. Okay, unlike solving, simplification is quite different from solving. Remember, solving means you should find the variables in the equation, but simplify, as it sounds, simplify, it means make it simple. Make it simple. So this is a very complex and long, it's not an equation, long expression. So we have to simplify it, make it simple. So how do we do that? Of course, it's not an equation, so we won't be dividing both sides by anything. So the right thing to do here is to just collect the like terms. Okay, there are terms that look alike here, even though all of them look alike, but not exactly. Okay, if you notice, the variable x in this expression is raised to different powers, and that makes the terms different. So x squared is not the same thing as x. X cubed is not the same thing as x raised to power 4. It's not the same thing as, they are different. So you have to just collect the like terms, advisably starting from the one with the highest power. So the highest power here is raised to power 4, and thank God it is even positive. If it is negative, you have to just leave it as it is. There's no equals to sign, so it won't be crossing any equals to sign. So we start with the highest, the one with the highest power. So that will be 3x raised to power 4. Is there any other one that is x raised to power 4? There isn't. So we move to the next one, which is x raised to power 3. So these has x raised to power 3. So that will be minus x raised to power 3. Is there another one that has x raised to power 3? Yes. Minus 4x raised to power 3. Is there another one that has x raised to power 3? No. So you move to the next one, which is raised to power 2. Okay, these has x raised to power 2. So that will be plus. Remember there is plus here. It actually means plus 2x squared. So 2x raised to power 2. Is there another one that has x raised to power 2? Yes. Plus 8x raised to power 2. Is there another one that has x raised to power 2? No. So you move to the next one, and that should be the one that has just x, which means x raised to power 1. Okay, this one has 5x. Is there another one that has x? Just x, yes. Plus 7x. Is there another one that has x? Just x. Okay, no, that's all. Then the next one will be the ones that are just whole numbers or letters, sometimes, that are not x. X is also a letter. So this one has x, this one has whole numbers. Okay, we have minus 21 and plus 16. Okay, so that will give us, okay, this one is the only one that has x raised to power 4, so you just repeat it. X raised to power 4, 3x raised to power 4. Now, remember we are not multiplying here, so we can't apply this. So you apply the depth I have rule. Okay, minus means depth, and plus means what you have. So I have a depth. Remember, it is x raised to power 3 and also x raised to power 3. So naira, dollars, orange, mangoes. You understand? All right. So you make sure that is settled. That is what collecting like times is all about. So minus x cubed. So minus x cubed means minus 1x cubed. Just like minus 1 naira. So I owe 1 naira and I owe another 4 naira. So that means I now owe 5 naira. And in this case, our naira is actually x raised to power 3. Do you understand that? I'm sure you do. Okay, let me just repeat. Minus means debt. I have a debt of 1 naira. That is 1 minus 1x cubed. So I have a debt of 1 naira. I still have another debt of 4 naira. So a debt of 1 naira, another debt of 4 naira. So the debt becomes 5 naira. So that is what brings about minus 5. Then the naira actually is x raised to power 3, x cubed. Okay, so that's evaluated. We move to the next one. These are also like terms, x squared, x squared. Plus means what you have. I have 2 naira and I have another 8 naira. So now I have 10 naira and what you have is plus. So that's plus 10x raised to power 2. Okay, you move to the ones that have x. So I have 5 naira and I still have 7 naira again. So that means I now have 12 naira, 12x. Do you understand? Of course, I am sure you do. Okay, and the last one, the whole numbers. I owe 21 naira. I owe 21 naira, and I now have 16 naira. I have a debt of 21 naira. So if I pay 16 naira to the person I owe 21 naira, will I still owe? Yes, I'm still owing 5 naira. So owe means minus, and I owe 5 naira. Okay. I'm very sure you understand that. So we have collected the like terms. And is there anything else we could do here? Nothing. So that is the simplification. So you notice this long expression here has been reduced by collecting the like terms and evaluating them. Alright, so that's the final answer. 3x raised to the power 4 minus 5x cubed plus 10x squared plus 12x minus 5. This type of question comes out mostly in objective questions. So let's quickly go to the next question, which is example 2D. And that says, okay, let me just start that on a fresh page. Okay, example 2D. Also simplification, but this time we have 8a minus 3 into bracket 2a minus 3b. Okay, we are asked to simplify this, of course. That means we should make it simpler. We should make it simple. It's a little bit complex. So, of course, there is not an equation. We cannot divide both sides. It has just one side. So we can't divide both sides by anything. Okay, could we? The next is collect like terms. You ask yourself, can I collect like terms here? Of course I can't. I can't. Why? One of the rules to apply collecting the like terms is that there must not be brackets, right? But there is bracket here. So you have to deal with the bracket first before you could collect like terms. But of course it's a straight line equation. It's not even an equation. There are no fractions. So that one is settled, but there are still brackets. So you can't collect like terms here. Can't collect like terms at this stage or level. So as I said, the right thing to do here is you open the bracket. So we have 8a. Now opening the bracket, you use, how do you open brackets? Of course, one of the principles listed in the first lesson is the principle of opening the bracket, the use and the opening of brackets. So here we, though we still treat it as a topic, a subtopic, but let me just briefly explain what it means here. So before you could open any brackets, it means there will be some terms or a term outside the bracket, and there will be some or a term inside the bracket. There is outside, there is inside. So the idea is you use each of the terms outside the bracket. Don't forget the signs. If it is plus, you use the plus. If it is minus, you use the minus. So you multiply each of the terms outside the bracket by each of the terms inside the bracket. Okay? Now, this can be somehow confusing, and that is where use of bracket comes in. This actually means 8a as a term on its own. Bam. Then we have minus 3 multiplied by 2a minus 3b. 2a minus 3b inside the bracket. So this 8a has no business. I told you terms are separated by plus or minus. So there are just two terms here. And the terms are 8a and minus 3 into bracket 2a minus 3b, no matter how complex it looks, it is still just a term. So we have these ones are regarded as just an entity because they are together. So that's why they are inside the bracket. So there are just two terms here, 8a and minus 3 into bracket 2a minus 3b. It's just like saying 8a minus 3z, where our z is what? 2a minus 3b. Do you understand? I'm sure you do. Alright, so don't confuse it for saying 8a minus 3 separately, then in bracket 2a minus 3b. No, that will be wrong. If it is in that way, it will be better expressed this way: 8a minus 3 bracketed, and then 2a minus 3b also bracketed. So these and these are not the same. This means something multiplied by another thing. It's just like saying 7 multiplied by 8. So 7, or saying mn, where m is 8a minus 3 and n is 2a minus 3b. And that's not what is given in the question. So back to the question. So as I said, this actually means 8a as a separate term on its own, then minus 3 into brackets 2a minus 3b, another separate term on its own. So we open the bracket, which has business only with the second term. So 8a minus 3 into bracket 2a minus 3b, then close bracket. So as I said the other time, I told us the right way to open this kind of bracket is you multiply each of the terms outside the bracket by each of the terms inside the bracket. So luckily for us, there's just one term, one number, minus 3 at outside the bracket in this case. So we multiply minus 3 by 2a. So minus 3 times 2a, minus 3 times 2a. Remember, 2a actually means plus 2a. So you multiply the signs first. Minus times plus. The signs are different. Minus times plus. The signs are different. So the result for the multiplication will surely give us minus. So that will be minus. Then you also multiply the numbers. 3 times 2. That's 6. So that will give, 3 times 2a rather. That's 6a. So minus 3 times plus 2a will give us minus 6a. Alright? So remember, you multiply these by each of the ones inside the bracket. So we've multiplied it by 2a, it remains minus 3b. So also we have minus 3 multiplied by minus 3b. So you multiply the signs first. Minus times minus. The signs are the same. So the result of the multiplication will be plus. So then you multiply the numbers to the numbers and letters. So 3 times 3b. 3 times 3b will give us 9b. So that will give us plus 9b. Okay? Alright. So having opened the bracket, you see that it looks more simple. We can relate more with this than the previous expression. So remember, we are simplifying. We are making it simple. So could we now collect like terms here? Yes, you agree with me that we could. Why? Because it's a straight line equation, not an equation though. It is straight line expression, which means there are no fractions, and also there are no brackets. The bracket has been dealt with. So you collect the like terms. So we have 8a. Is there any other term that has? Now the 2 times here, when we open this bracket, which is a term, it now gives 2 more terms. So instead of 2 terms altogether, we now have 3 terms, having opened the bracket. So 8a is a term, minus 6a is a term, plus 9b is also a term. So is there any other term that has a in it? Yes, and that's minus 6a. So you bring them together, minus 6a. They are not equals to sign here, so it's not an equation. So you just proceed. So the only remaining term here is plus 9b. So you just write it plus 9b. Okay? The terms are already collected, so it's just like repeating the expression again. So let's proceed. So 8a minus 6a, a and a, naira and naira, dollars and dollars, orange and orange, mangoes and mangoes. Yeah. So 8a minus 6a, remember plus is what you have and minus is your debt. So I have 8 naira and I have a debt of 6 naira. So that will give me, I'll even collect change now. So I will still have, after paying that 8 naira, I will still have 2 naira. So that's plus 2 naira. So that you don't need to write a plus. So that will be 2a. Right? Yeah. Then plus 9b. So this is the final answer, the result of the simplification. Okay, let's quickly go to the next example, which is example 2e. The question says, if 3y plus 4 minus y all over 3 equals, okay, let me write it so that it will contain it. 3y plus 4 minus y over 3 equals y plus 9. Find the value of y. So we are looking for the value of the variable y in this equation. Okay, so how do we go about that? Remember, we are treating collecting the like terms, the principle of collecting the like terms. When do we collect like terms? Could we apply this principle at this stage? No. Why can't we? We can't, because if we remember, the first rule to applying the principle is that it must be a straight line equation or an expression. It is not. There is a fraction here, so we have to deal with it first. Okay? And also the second thing that must be ascertained is that there must be no bracket. Luckily, there are no brackets, so it's just the fraction that is disturbing us from applying the principle of collecting the like terms. So we have to deal with this fraction. How do we deal with it? There are different ways you could, but the simplest and the most comprehensive way, simple and comprehensive way to deal with this fraction is by multiplying through by something, which is among the principles I listed earlier in the first lesson. Okay, so that's what we are going to do. That's one. And secondly, I said something the other time that whenever you are working with fraction and you have whole numbers, it's better you make the whole numbers what? You make the whole numbers fraction. So when there is a fraction here, y all over 3, you can make this one 3y all over 1 plus 4 all over 1. So it will be the same thing, everything will be fraction, y all over 1 plus 9 all over 1. So the next thing will be to find the LCM and all that, but that will be a long method. So the best way, as I said, the simplest and comprehensive, most comprehensive way to go about this is just to multiply through. So we can't collect like terms at this stage. Alright, so as I said, the right thing to do here is to multiply through by something. Though we'll still treat it also in subsequent subtopics. But what does it mean to multiply through? Okay, you multiply through means you multiply each of the terms of that equation or expression. So 3y is a term, 4 is a term, minus y all over 3 is a term, y is a term, plus 9 is also a term. So you multiply each of those terms by the LCM of the existing denominators. There's just one here, 3. So the LCM is also 3. So you multiply through by 3. But in case there are more than one denominators, for example, if this 4 is 4 all over 3. No, don't let me use 3. Okay, don't let me use this. Okay, let's say it is 4 over 7. So we have 3y plus 4 over 7 minus y all over 3 equals y plus 9. So you you multiply through, that is, you multiply each of these terms by the LCM of the existing denominator. So in this case, we have 7 and 3. So you find the LCM of 7 and 3, which is 21. So you multiply each of these terms by 21. That is 3y times 21, 4 all over 7 times 21, y all over 3 times 21, y times 21, 9 times 21. And you will now see that the fraction will be dealt with. Okay, let's even quickly do that now. So 21 times 3y, that will give us 3 times 1, 3, 3 times 2, 6. So that will give us 63y. Then plus 4 over 7 times 21. 7 here 1, 7 here 3. 4 times 3, that's 12. So that will give us 12. Minus y all over 3. Y all over 3 times 21. So 3 here 1, 3 here 7. So 7 times y will have 7y. So that will give us minus 7y. Equals 21 times y. That's 21y. Plus 21 times 9. 21 times 9. 9 times 1, 9. 9 times 2, 18. That will give us 189. You see that there are no fractions again. And it doesn't mean the question has been changed. We have not changed any question. If you still divide through by 21, you still get back the question. So it's still the same thing. So it's just a very smart way to go about solving this type of question. So back to the main question we're solving. So since we can't collect like terms at this stage, we'll multiply. The right thing to do is to multiply through by the LCM of the existing denominators. So luckily here is just 1. So the LCM of 3 is 3. So you multiply through. Therefore, multiply through by the LCM of 3 is 3. Okay? Sorry, we've solved question C, so permit me to rub these off. Alright, so we are multiplying each of the terms here by 3. So 3 times 3y, that will give us 9y, right? So that will give us 9y, okay? This doesn't mean equals to, just like leading us to, from here, come here. So 3 times 3y, that's 9y, plus 3 times 4, that's 12, then minus y all over 3 times 3, or 3 all over 1, 3 times y all over 3, 3 here 1, 3 here 1, so it remains just y. So that will give us minus y equals 3 times y, 3y, plus 3 times 9, 3 times 9, 3 times 9, 27, right? 27. Okay? Now, you agree with me that we could collect like terms now. There are no brackets and there are no fractions. Okay? So how do we collect like terms? So we have 3 of the 3 terms here that has the variable y we are looking for in them. So we bring them together, And remember, I told you that you maintain the side that will make the biggest among all these times a plus. So that's the biggest is 9y and it is plus on this side. So just maintain this side. So that will be 9y. Any other one with y, yes, minus y. It's not crossing the equals to sign, so you maintain it. It will still be minus y. Then another one that has y is 3y. It is on the other side of the equation, so you bring it to this side to become minus 3y. Remember, if it was plus, it becomes minus. If it was minus, it becomes plus. Okay, so that's all for the terms that have the variable y we are looking for. So you introduce your equals to sign. Remember, I told you that you write the other terms that are not going to change signs. They are not moving anywhere. So 27 in this case, so you just write your 27. If you write plus 27, you are still right, but why write it is not necessary, really. So 27, is there any other one that looks like it that is another term other than the one that has y? So that's plus 12. This one is going to the other side, so it's moving to the other side, so it's become minus 12. Any other terms? No. So that's that about that. So I have 9 naira. I owe 1 naira. And I owe another 3 naira. So if 9y minus y, I have 9 naira, I owe 1 naira. So that will be 8y, if you agree with me. So I will still have 8 naira. So 8 naira minus 3 naira. I have 8 naira and I owe 3 naira. So if I pay that 8 naira to the person I owe 3 naira, I will still have 5 naira. So 9y minus y, that's 8y. 8y minus 3y, that is 5y, equals 27 minus 12. 27 minus 7, that's 20. 20 minus, that's 15. So that's 15. Okay? Now, we have collected the like terms and we have evaluated. Oh, sorry, I didn't write the principle again. Oh, forgive me. I don't want to rub these off. Just shorten the y. Okay, so collect like terms. Alright, so from there we collected the like terms and we evaluated to get 5y equals 15. You agree with me that the best and the right principle to apply here is to divide both sides by something. And what do you divide both sides by? The coefficient of y, which is 5 in this case. So divide both sides by 5. So the first side we have 5y and the second side we have 15. So the first side divided by 5, the second side also divided by 5. So 5 here 1, 5 here 1, 5 here 1, 5 in 15 is 3. Okay, therefore, oh my. Okay, permit me to rub these off. That's example E. Okay, Chimis Joseph. Okay, so from there, our final answer, permit me to demarcate these. So our final answer, we have just y on this side equals 3. So that's the final answer. I hope we understand. I'm very sure we do. Okay, let's quickly go into solving the last example that we have, and that's example 2f. The question says find the value of x for which 5 over 2 plus x equals 3 over x minus 2. So we have 5 over 2 plus x equals 3 over x minus 2. Okay? How do we solve this kind of equation? It's quite different from the ones we've been solving. Okay? Let's start from dividing both sides by something. Could we apply that principle here? No. Why not? Because to apply the principle of dividing both sides by something, it has to be a straight line. Okay? Not really straight line equation. Okay, that's not it. Can someone remind me there? Divide both sides by something. Okay, the first thing is that the term that has the variable you are looking for must be on one side and every other term on the other side. And what do you divide both sides by? You divide both sides by the coefficient of that variable. So in this equation we could see that we can't apply that principle. The term that has what we are looking for, which is x is what we are looking for, is not on one side and the other is on the other side. So we can't apply dividing both sides by anything here. So let's move to the next one, which we are considering now. Let's see if we can collect like terms. We can't collect like terms. Why? Because there are fractions there. Okay, so we can't divide both sides by anything, nor could we collect like terms because there are fractions there. So what do we do? In the previous example, example 2e, when we couldn't collect like terms, we multiplied through by something. Let's see if we could multiply through by anything. Remember, you multiply through by the LCM of the existing denominators. But in this case, wow, it is much more, the denominators are even much more complex. So we could actually multiply through by the LCM of the denominators, but I won't advise you do here because there is a simpler and more comprehensive way to solve this kind of question other than multiplying through by something. So not the one, well, we still treat more questions on multiplying through by something when we get to that level. So what you could do to this is we will just cross multiply. So which is also part of the fundamental principles we listed in the last lessons. So we'll cross multiply. Now, what is the reason why cross multiplication is the right one to apply at this stage? You apply cross multiplication when you have fraction, one fraction on one side of the equation and on the other side also just one fraction. No matter how complex it looks, 5 all over 2 plus x is just one fraction, and it is the only one on the left hand side of this equation. And also 3 all over 3 minus 2, x minus 2 rather, is the only fraction or also on the right hand side of the equation. When you have something like this, then the next thing, don't think twice. You just do what? You just cross multiply. So you do what? You cross multiply. We'll still treat it much more when we get to that place. So you cross multiply. So if you cross multiply, what happens? Just as it is said, cross multiply, it means you are actually multiplying, but in a cross form, in a cross path, not direct path. If you are to multiply directly, that will be 5 times 3 equals 2 plus x times x minus 2. But here we are not doing that. We are cross multiplying. We are multiplying but in a cross path. So I don't want to do this because we have to be careful, especially when we are writing an external examination, standard examination outside our schools. We never can tell who will be marking our script. So the person could be angry, and when he sees something like this, he could think you cancel, and he just so that's why I won't advise students to just put this sign. The person could misinterpret it as you cancelling your work. So it's better you just write cross multiply. So if the person sees that, he knows that you are cross multiplying, and from the previous stage you come to the next stage of cross multiplication. Okay, so if you cross multiply, it means 5 multiplied by x minus 2, 5 multiplied by x minus 2 equals 3 multiplied by 2 plus x. I've actually utilized another principle we'll later consider here, and that's the principle of the use of brackets. You notice that there are no brackets here before, but while I cross multiply, I introduce bracket. Why? The reason is that this is not just one entity. Okay, I'm multiplying 5 by x minus 2. If it is just x, I don't have to introduce bracket. So 5 times x will just give me 5x. But I'm multiplying 5 by x minus 2. So if I don't introduce bracket and write it this way, 5 times x minus 2. Do you know it could mean different thing? It could mean 5 times x, which is 5x, then minus 2, which is not what we actually need. What we actually, it could also mean 5 then multiplied by x minus 2. Do you see where the bracket comes from? So if you had done it this way, you would have been wrong. So that is why whenever you are dealing with more than one entity that are together, the best thing is to just introduce a bracket to avoid confusion. So that is why I introduced bracket here. So 5 times x minus 2, to show that 5 separately is multiplied by x minus 2, which are together. Then this one too, 3 also multiplied by 2 plus x, which are together. So the bracket is just showing that they are together. No, we'll solve more examples when we get to that principle. So let's just proceed from here. Okay, but before I proceed, so we have cross multiplied here and we introduce bracket. So could we now divide both sides by something? No, we can't. Why not? Because the term that has what we are looking for is not on one side and the others on the other side, so we can't. Could we collect like terms? No, we can't. Why not? Because there are brackets there. And remember, to use the principle of collecting like terms, there shouldn't be brackets there. So what do? You have to open the bracket, just like this. You have to open the bracket. So let's go and open the bracket. So opening the bracket, you multiply the number outside by each of the ones inside the bracket. So 5 times x. X means 1x. So you multiply the numbers for us. 5 times 1, 5. And there are no letters for this one, so the only letter here is x. So 5 times x is simply 5x. And then 5 times minus 2. Plus times minus, the signs are different. So the result for the multiplication will be minus. Plus times minus is minus. Then 5 times 2 is what? 10. The bracket opened. Equals 3 times 2 plus times plus. That's plus. The signs are the same, so it will be plus. So you don't have to write it because it's the first one you'll be writing. So just write your answer. 3 times 2, that's 6. Then plus times plus is 2 plus. 3 times x, that's 3x. Okay? Okay, let me write open the bracket. Open the bracket. That's the principle we apply there. So to get this, so could we now divide both sides by something? We still can't, because the term we are looking for the term that has the variable we are looking for is not the only one here. We have 5x here, but minus 10 is here, and even in fact, another 3x is here. So we can't divide both sides by anything. Now, could we collect like terms? Okay, it must be a straight line equation. That is, there should be no fractions. There are no fractions. The first rule satisfied, and the second rule says there must not be brackets. So there are no brackets. So it has satisfied the two rules, and now we could collect like terms. Okay, so remember, you start with the terms that have the variable you are looking for, and with the biggest, making sure that it is plus. So the biggest, okay, they are just to the bigger one here is 5x, and it is plus on this side, so you just maintain this side. So we have 5x. Any other one with x? Yes, 3x is on the other side, so it has to come to this side. It was plus, now it has to become minus 3x. Is there any other term with x? No. So introduce your equals to sign, and after that, remember I told you that you always write the ones that doesn't have to change, the one that doesn't have to change any sign. So 6 is already here, so it's going nowhere, so you just write your 6. But this minus 10 is coming to this side, so it will become plus 10. So the terms, the like terms, are collected. So I have 5 naira and I owe 3 naira. If I pay that 5 naira, I will still have 2 naira. So xx, remember. Okay, so that will give us 2x equals 6 plus 10. I have 6 naira and I have another 10 naira. So now I have 16 naira. So 2x equals 16. Okay? So at this stage, we have collected the like terms. I said something the other time that after collecting like terms, usually the next principle to apply most times is divide both sides by something. So could we apply divide both sides by something here? Yes. Why? Because the term that has what we are looking for is on one side, that's 2x, and the times, other times are on the other side. So we can divide both sides by something. And the second rule is you divide both sides by the coefficient of that variable you are looking for. So you divide both sides by what? The coefficient of x, which is 2. So on the first side we have 2x, and on this other side we have 16. So the first side divided by 2, the second side also divided by 2. 2 here 1, 2 here 1, 2 here 1, 2 in 16 is 8, and our final answer is 8. So x equals 8. And that's the end of today's lesson of collecting the like terms. I hope you understand. So before we close finally for this lesson, you will notice I was doing something frequently. At every stage, I start to test. I started by testing if I could divide both sides. So I will advise that whenever you get to any stage while solving mathematics, you make it in that sequence. You check if you could divide both sides by something. If you can't, you go to collecting like terms. If it can't, you go to the next one we'll be solving. It's a series now, so we'll just maintain that sequence. So thank you.